Hello guys, welcome back to my YouTube channel. So today we are going to solve day 29 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2577. Minimum time to visit a cell in a grid. Okay, so in this problem you are given a m into n matrix grid consisting of non-negative integers. Okay, and where each cell represents the minimum time required to be able to visit the cell. Okay, so if I want to move to this cell, so minimum time required should be 1. Okay, and if I want to travel to this cell, minimum time should be 3. Okay, if I want to move to this cell, minimum time should be at least 2. Okay, or greater than 2, then it's fine. Okay, but minimum time should be this value. Okay, so this is given to us. Okay, you can visit the cell only when the time you visit it is greater than or equal to that particular cell value. Okay, so this is what given here, right? And you are standing in the top left cell. Okay, here you are standing at this position. Okay, top left cell of the matrix in the 0th second. Okay, so this value is always going to be 0. Okay, in the starting, and you must move to any adjacent cell in the 4 directions. Okay, up, you can move up, you can move down, you can move to the left side, you can move to the right side. Okay, each move you make takes 1 second. Okay, so from here you have two options now. So you can move to this direction or you can move to this direction. Okay, there is no value here, no value here, so you can't move to these two directions. So only two possibilities, right? So here if you are making a move, so it is going to take 1 second. Okay, it is going to take 1 second, right? Only then you can make a move, right? Each move you make takes 1 second. Okay, so we have to turn the minimum time required in which you can visit the bottom right cell of the matrix. Okay, so here this is your destination. If you cannot visit the bottom right cell, then you have to return -1. Okay, so here one initial case, if I want to visit this cell, my time value should be at least 5. Okay, and if I want to visit this cell, my time value should be at least 1. Okay, so this is what this matrix represents, right? So here from this cell I can't move to this cell, right? Because in once here it is going to take 1 second, and here this cell is saying that at least 5 should be there. Okay, but here only 1 second will be there, right? So I can't move from 0 to 5, right? So 0 to 5, only 1 second is there, right? So my time value is going to be 1 only, but here I want at least 5. Okay, but from here I can move to this cell. Okay, because here if I'm moving from this to this, time is taking 1 second, and in 1 second I can reach to this cell. This cell is telling me that in 1 second, if you have time value 1 second, you can reach at this particular position. Okay, so here if I make a move, definitely my time is going to update to 1 second and I can reach here. Okay, but here instead of 1, if the value is 7, if the value is 7, let's say, so here I am starting here at this position. Okay, I can't make a move to this one. Okay, because in 1 second I am reaching at this particular cell, but here it is saying that at least 7 seconds should be there. Okay, at least in 1 second only I am reaching here, but it is saying that at least 5 times should be there. Okay, 5 second time should be there. So in that case there is no possibility to make any move, right? So in that case I'm simply going to return -1. Okay, so this is the only case where I am going to return -1. Okay, because here in the starting I can't make a move to any other cell because time values is 5 and here let's say 7. Okay, so first base condition is going to be if I am at the starting position. Okay, if I am at starting position, then I will check if my next cell value is greater than 1. Okay, here, and if this cell, okay, at this position, if this value is also greater than 1, then in that case simply return -1. Okay, return -1. Okay, because here I can only make time as 1 second. Here only I can make time as 1 second. So if any one value, okay, if both these values are greater than 1, then simply return -1. Okay, so I hope that you guys are clear with this, why we are returning -1 in this case. Okay, so now let's understand it further. Okay, so this is run. Now after that, okay, so here let's say I make a move. I can't move to this cell, but I can move to this cell if this value is just 1. Okay, so now I reach here, I reach here. Okay, so at t is equal to 0, we are on cell 0 by 0 here, right? At time is equal to 1. Okay, so I make a move, so we move to the cell 0 by 1. Okay, so 0 1. Okay, so here let me do one thing. let me create this matrix here. Okay, so here this we have four four columns and three rows. Okay, four columns and three rows. All right, so this is my matrix. Okay, so now let me just assign indexes. Okay, 0 row first row, second row, 0 column first column, second column, and third column. Okay, and the values are 0 1 3 2, 0 1 3 2, and then we have 5 1 2 5, 5 1 2 and 5, and then we have 4 3 8 6. Okay, 4 3 8 6. Okay, so now I make a move from here to here. Okay, in 1 second. Okay, 1 second, right? So now after that, here I have two options now. Okay, so here I will check one thing. Okay, so here I have two options. I can move to this cell, I can move to this cell also, right? And what I'm going to do, I'm going to mark it as visited. Okay, this cell I have already visited in the start, so I'm just going to mark it as visited. Okay, with blue pencil. So this is nothing but visited. Okay, now after that, after this cell I move to this cell, so I mark it visited. Okay, this has visited. Now from here I have two options. I can move to this one and I can move to this one. Okay, so here see, from here I have two options. I can move to this cell and I can move to this cell. Okay, so here this is given that we can move back to any cell. Okay, we can go back and forth. Okay, so here uh, let's say this is my cell. Okay, and from here I move to some other cell. Okay, let's say its value is 1. Okay, here at t is equal to 1 I reach at this particular cell, time is equal to 1. Okay, at this, okay, this cell is 0. Okay, and I'm going to mark it as visited. I'm going to mark it as visited. Okay, so here after that there is another cell. Okay, which is saying that time should be at least 5. Okay, your time should be at least 5. So here in the problem statement it is given, okay, that we can visit. Okay, so this is just for my reference, I am marking it as visited, but in reality you can visit back and forth. Okay, so what I'm going to do here, see, so total time difference. Okay, here time is equal to 1 and here to reach at this cell time is 5. Okay, so here what is the difference between them? 5 minus 1. Okay, is equal to 4. 4 is the difference. Okay, which is even. Okay, this is nothing but even value. Okay, so now I'm going to show you why I am considering this as even. Okay, so why I'm going to use it okay, later on if it is even. Okay, so now here see, I can do one thing. Here t is equal to 1. Okay, so now here I can do one thing. I can move back. My time is going to become 2. I can again move to this cell. Okay, time is equal to 3. Okay, then again I can move to this position. My time is going to become 4. Now again I move to this cell, t is equal to 5. So now in t is equal to 6 can move to this cell. Okay, t is equal to 6. At t is equal to 6 I can move to this cell. Okay, so here you are going to treat it as visited only. Okay, in question you are going to treat it as visited, but here I am going to show you how we can move to this cell. Okay, how I'm going to visit this cell. So how many steps you are taking, so how much time or steps you are taking. Okay, so here one step, this is second step that you are taking, this is third step you are taking, this is the fourth step you are taking, and this is the fifth step that you are taking. Okay, total 5 steps, 5 more steps. Okay, so in t is equal to 6 you are reaching to this position. Okay, in t is equal to 6 you are reaching to this position. Okay, t is equal to 6. Okay, so if difference is even, okay, if the difference is even, then you are going to reach to the next cell in the next cell value plus 1, next cell value wait time plus 1. Okay, this is going to be your answer. Okay, 6 at t is equal to 6 you can reach here. Okay, you doing going back and forth. Okay, you can reach at this particular position. Okay, so now let's say if this cell is 0, okay, and next cell you move, you are taking only 1 second now. After, before moving from one cell to another cell, you are taking only 1 second always, right? So here you move to this cell, so your time is going to become 1 second. Okay, then after that there is one cell whose value is 4, okay, which is asking that at least 4 should be the time. Okay, only then you can reach here. Okay, so here what is the time difference here? 4 minus 1, 4 minus 1, time difference is 3. Okay, which is nothing but odd. Okay, so now see here what I'm going to do. So here I can't move to this cell. Okay, 1, if I move to this one in the 2 seconds, then it is not a perfect answer, right? So my this t value should be equal to 4 or greater than equal to 4. Okay, so this is what I need. Okay, so here what I'm going to do, I'm going to make a backturn in t is equal to 2, then I'm going to back to this position, t is equal to 3. Now see carefully, now I can move to here, t to 4. So t to 4, so if my time is odd, I am going to reach to the next cell in just 4 seconds. Okay, in just 4 seconds, and there is no addition 1 that I'm using. So here t was coming as 6. Okay, 1 extra as per this cell value, one extra, right? If it is even. So if it is odd, then I'm getting exact. Okay, right? So we can go back and forth, but this option was not available when we were at starting position, because from here I can't move to back to any other cell. So that is why I told you in the beginning only that if you are at starting cell and then you have to check if this cell and this cell value is greater than 1, then simply return -1, because if you are at other positions you can go back and forth. Okay, so okay, you can go back and forth, this is one thing. And one more thing that is clear, that if the difference is even, then here just add 1 extra. Okay, in 1 extra time you are going to reach to the next cell. Okay, 5 plus 1 6, at t is 6 you are going to reach here. If the difference is odd, then just give the wait time as 4 only. Okay, no need to add extra 1. Okay, so now here, now see carefully. Okay, so now I'm going to solve this problem. Okay, but I hope that you guys are clear. Okay, so here now see, I am at this cell 0 by 1. Okay, 0 by 1, I am at this cell 0 by 1. So it is possible because grid 0 1 value is less than equal to 1. Okay, so now at t is equal to 2, we move to the cell 1 by 1. Okay, so we can move to this cell 1 by 1. Okay, okay, I'm going to mark it as visited, right? I'm going to mark it as visited. Okay, this is nothing but at t is equal to 2. Okay, t is equal to 2. Now at t is equal to 3, we move to the cell 1 by 2. 1 by 2. Okay, at t is equal to 3 second, we move to the cell, this cell. Okay, and I'm going to mark it as visited. Okay, I'm going to mark it as visited. Okay, so now here see, if you are here, so now you can't move to this cell, you can't move to this cell. Okay, so if you are moving to this cell, then it is taking 4 seconds. Okay, it is taking 4 seconds only, you can't move to this cell. If you are moving to this cell, it is also taking 4 seconds, but you need at least 8. Okay, so you can't move here as well. So now what you are going to do, but you want to move to the next position. Okay, so here t is equal to 4, at t is equal to 4, what it is doing, it is just going to move to the cell 1 by 1, again moving back to this cell. Okay, so t is equal to 4. Okay, right, and t is equal to 5, it is again moving to this cell at t is equal to 5. Now this cell can move to here at t is equal to 6. Okay, t is equal to 6, it can move to this cell. Okay, and at t is 7, it can move to this cell as well. Okay, so here see these steps now. 2, okay, at 3 I'm reaching here, then it did 4 and 5 and then 6. Okay, so here now let's do one thing here. uh, you are reaching to this cell in time is equal to 3. Okay, in the starting. Okay, t is equal to 3, you are reaching right here. Just follow this blue brown pencil. Okay, time is equal to 1, time is equal to 2, time is equal to 3. So at t is equal to 3, you are reaching at this cell. Okay, then if you want to move to this cell, so this cell value is 5, so 5 minus 3, difference is even. Okay, 5 minus 3, difference is even. Okay, so if difference is even, so what you are doing, if difference is even and you want to move to this one, so you are just going to add 1 to it, 6. So this is what's coming here, t is equal to 6, so directly t is equal to 6 coming. Okay, I have shown you visually right here 3 4 5 6, but directly we can calculate if from 2 to 5 I want to move. Okay, this 2 value to 5 value. Okay, so at t is equal to 3, from t is equal to 3. Okay, here value was 3 now, so from 3 If I want to move to 5, I will just calculate the difference. If it is even, I'm going to add 1 and then I can move to this cell. Okay, that's the only tricky thing. Okay, so that's what we need to do, right? So we are going to mark it as visited. Okay, so I don't want to visit them again, but I am going to get the values directly. Okay, so here 2 to 5, I get the value, whatever value possible. Okay, so I get that value. That's it. That's what we need to do. Okay, so now I'm going to write the code. Okay, code is going to be very simple for this one. I'm going to use a simple priority queue. Okay, in priority queue I'm just going to add the wait time and that particular cell, row and column. Okay, and it is going to be mean heap. Okay, the smaller value is going to be come to the top. Okay, smaller wait time is going to come to the top. Okay, and I'm going to create a boolean listed array. Okay, and yeah, I will explain my code side by side as well. Okay, so now let's write the code. Okay, so here you can do one thing. First calculate the m and n value, number of rows and number of columns. So here it is nothing but grid dot length, right? And n is going to be grid of 0 dot length. Okay, now here just check one condition. If grid of value greater than 1 and grid of value greater than 1, then in that case simply return -1. Okay, so what value? This cell value, this cell value. Okay, and this cell value. So here I can write it like this, 1 0, right? I can write it like this, 1 0, and here I can write this as 0 1. Okay, 0 1. Okay, and here see constants. So m and n value always greater than equal to 2. Okay, so this condition is satisfied. It's not like this column does not exist. Okay, so this cell is going to be there because here in the constant it's given that m and n value is always greater than equal to 2. Okay, and less than equal to 100. Okay, this is given to us. Okay, so we can directly give this condition, and from here we can directly return -1. Okay, because in this cell, if we are at this cell, we don't have any option to go back and forth. Okay, because we are starting from here only, but in other position, other cells, we have going back and forth position. Okay, and every move is going to take 1 second. Okay, so that's what. So here this is done. Okay, so now after that, directions. Okay, so we are going to create one directions array, and this is very simple. Okay, so if you are in this cell 0 by 0 and you are moving to the this side, okay, this cell, let's say. So here if you are moving to this cell, you are remaining in the same row, but your column is incremented, right? Your column is incremented. Okay, if you are moving to this position, so you are remaining in the same row, but your column is decremented. Okay, so if you are moving up, your row is decremented, right, and column remains same. If you are moving downward, okay, so your row is going to be incremented and column will remain same. Okay, so you can understand it using this matrix. Okay, so you are here at this position. Okay, at this position. Okay, so if you are moving up, your row is decrementing, right? This is previous row, right? If you are moving here, your row is incremented. If you are moving here, your column is incremented. If you are moving here, your column is decremented. Okay, that's it. So I'm just going to create one directions to the array. Okay, so I hope that you guys are clear how we are taking these directions. Okay, int directions is equal to, all right, so here we need to give something, and here we need to give something. Okay, so now let's just put these values, -1 0. Okay, all these values we are going to put. So here you can give a 1 comma 0. Okay, 1 second. Here you can give 1 comma 0. Okay, here you can give -1 comma 0. Here you can give 0 comma 1, and here you can give 0 comma -1. Okay, so these are the directions. All right, so now once this is done, now also create one boolean visited array. Okay, so here I'm just going to write boolean, okay, and visited is equal to new boolean, and here you can just give m and n. Okay, m and n. All right, this is done. So now once this is done, so we have to use priority queue, okay, to store time, row and column, right? And we are going to order it by minimum time to reach each cell. Okay, so here I'm just going to write priority queue, okay, int pq is equal to new priority queue, okay. And here you can say that if we have two arrays, okay, a and b, all right. So we have to sort them based on their start time, okay, a of 0 minus on their time only, okay, b of 0, okay. So this is done. All right, so now we are done with the priority queue. So initially just add the first value in my priority queue. So priority queue dot add new int. So here you are going to pass grid 0 by 0 value is always going to be 0 only, right? So this is what you are going to pass, grid 0 by 0 value is 0, so I am directly writing 0 here, okay. So this is done. Now here we simple Dijkstra's algorithm that we are using, right? So we have solved yesterday's and I think 2 days back problem with the Dijkstra's algorithm only, right? So here while priority queue is not empty. All right, so here in this case first take the current element, int cur is equal to pq dot poll. All right, now take time is equal to cur of 0, okay. Row is equal to cur of 1 and column is equal to cur of 2, okay. So now just check one base condition if we reach the target, okay. So if row is equal to m minus 1 and col is equal to n minus 1, okay, that simply means that we have reached the target. So from here simply run time, okay. So this is one thing, okay. And we have to skip if we have already visited the cell, okay. So for that purpose, if visited row and column, all right. So in that case simply continue, all right. And if now just mark it as visited, okay. If we haven't visited it yet, then just mark it as visited, okay. And now we have to check in all the directions, okay. Try all 4 directions. So here I'm just going to write for int the directions, all right. So here I'm just going to check first my next row is going to be int next row is equal to row plus d of 0. My next column is going to be col plus d of 1, okay. Col plus d of 1, right. And now I'm just going to check if the next row and the next column is a valid, okay, valid cell in grid, okay. So here if it is not valid, let's say if it is not valid, okay. So I'm going to call this is a valid method, okay. Here I'm just going to pass if I have already visited it, okay, then I'm not going to consider it, okay. And here I'm just going to pass next row, okay, and next column, okay. In that case, okay, if it is not valid simply continue, okay. And I'm just going to validate also if my next row and next column exists in my matrix or not. Okay, so I will define that later on. Okay, so if it is not valid, okay, if we have already based it, then also it is not valid. Okay, so here if it is valid, then we have to calculate the wait time needed to move to the next cell. Okay, so now I'm just going to calculate the wait time needed to move to the next cell. Okay, so from here 2 to 5, if I want to move from 2 to 8, I can move, right? So I just need to calculate the wait time. Okay, so here I know 2 to 5 I'm moving. Okay, so at this position time was 3, and here 5 time was 5. Okay, so here I just did the 5 minus 3 to even, so I'm just going to add is 6. Okay, so this is what I need to calculate the wait time. Okay, so using these two things, okay, even and odd, I will calculate the wait time. Okay, so here int wait time. Okay, how we are going to calculate the wait time? So here I'm just simply going to write grid. Okay, grid of next row and next column. Okay, grid of next row, next column. Okay, if grid of next row, next column minus time. Okay, if I did the modulus of these two. Okay, modulus of these two, because this is what I was doing, right? Here time was 3. Okay, so you can understand here now. So this time was 1, and here this time was 5. Okay, so 5 minus 1, I see the difference is even. Okay, so if the difference is even, okay, so here I'm just going to write is equal to 0. Okay, so if the difference is even, then wait time just take 1. Okay, otherwise take 0. So here wait time simply means that I have to add this one value. If here 5 plus 1. Okay, so if it is odd, then consider it 0 only, because I am adding 0 in 4. Okay, in this 4 I'm adding 0 only, right? So this is what I'm doing here. All right, so next time, this is nothing but wait time. Okay, so now next time is going to be, so I'm going to take the math.max of. Okay, math.max of grid of next row value. Okay, this value, and in this value I'm just going to add what wait time. Okay, if it is even, then it is going to take 1. If it is odd wait time, then it's going to take a 0. Okay, so here I'm just going to write wait time. All right, so this is done. Okay, so math.max between this, right, and uh, and you can say time plus 1. Okay, time plus 1, whatever the max value. Okay, we are just going to consider the max only. Okay, so here this is going to be my next time only, right? So now once this is done, okay, so here this ends. Okay, so once this is done, then we have to just write pq. Okay, in the priority queue dot add new int. Okay, so what I'm going to write, I'm going to pass in my next time and next row in my priority queue and next column in my priority queue. Okay, this is done here, and in the end here simply return -1. Okay, if we did not able to return this. Okay, if we didn't able to return this value, that simply means that we haven't reached. Okay, then we have to simply return -1. Okay, so this is done. All right, so now just write the code. So this is very simple, is valid. So you can write a private boolean is valid. Okay, and in this just pass the visited array. Okay, and you can pass row and column. Okay, int row, int column, and here inside this just going to check few things. Okay, so in the return, okay, so if your row should be greater than equal to 0. Okay, and your column should be greater than equal to 0. Okay, and your row should be less than visited dot length. Okay, and your column should be less than visited of 0 dot length. Okay, and you haven't visited that cell. Okay, this condition should be true. Row and column, that's it. Okay, that's it. So now let's run it and see if they encode issues. So yes, there are some issues. Let's try to fix that. So here grid of 1 comma 0 is greater than 1. Okay, and here I think this is a missing thing now. All right, now let's run it. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? Okay, so now what is going to be my time complexity? Okay, so since we are using the priority queue, right, and in the priority queue we are doing the operations, right, these all the priority queue operations, right, all the stuff that we are doing, adding the elements in the priority queue and the removing. So it is going to take log of m into n cells total we have, right? So log of m into n, okay, for the priority queue, and overall we are visiting all the cells. Okay, so m into n into log of mn. Okay, so this is going to be my time complexity. Okay, so m into n into log m into n. So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.